So hi everyone, my name is Yazid Boutejder. I'm a solutions architect with AWS. And today we'll be talking about production readiness. So how many developers do we have okay, cool. How many of you think whatever you shipped or whatever you ship is bulletproof? No one. What? You are overconfident. I'd like to talk to you after this session. So yeah, we'll talk about some tenets of best practices on how to be ready to deploy code. And there's about 9 of them. I know that typically, whenever you hear something about best practices, top 5, top 10, but this is 9, so bear with me. I'm working on number 10. So to get started, I need to make sure the clicker works. Yeah, there you go. So I want to start with our CTO, Werner Vogels, who said this in one of the sessions at reInvent. Everything fails all the time. So this is something that you should have as kind of a philosophy going into building your applications in the cloud. So always assume that things will fail. And as you probably know or experienced, software fails, hardware fails, a human error can be a failure. So try your best to always think before you build anything, okay, what can I do? How can we build this environment where a component can fail without impacting your business? So these are the 9 tenets I talked about. We're going to dive deep in each one of them, but at a high level right now. We're going to talk about architecture, design, and review. We're going to talk about monitoring and logging. We're going to talk about documentation and alerting, right? Service level agreements, SLAs. And we're going to talk about expected throughput, right? What is the expected state of your application and how to measure that? And we're going to talk about some testing and deployment strategies. One thing that's important here, if you are in an early stage in your kind of lifetime as a startup, it is not mandatory to have all of these right away. So this is kind of the building tenets. You can adopt a couple of them when you first starting, but as you grow, you want to make sure you're adopting more and more. So they're not a must right away, but it's good to have them in front of you and keep them as a target. So we'll review the architectural design, right? So I'll talk about the Netflix chaos engineering in a minute, but really you want to define your steady state. And what I mean by that is to define a steady state, you want to look at measurable outputs. And you measure the outputs by looking at error rates, latencies, transactions per second. And you want to define that so that you know how is my application going to behave or react when I have users trying to access my application or consuming my application. Now, once you define the steady state, you want to test that. So back to that earlier comment from that I opened up with, which is everything fails. So defining a scope is great. Now we don't know if it's going to react in real life or how it's going to react. So after you define your steady state, you want to make sure to hypothesize, right? And when you hypothesize, you want to run tests in a similar environment, right? Where you can actually run your application through a real workload. You can experiment with groups or in stable environments. You can expose your experiments to simulated real world. So production workload is in one environment. Try to emulate that production environment and send real traffic to it and see what kind of behaviors are you going to observe. And if you have less differences between the emulated environment, you're highly likely that you can think that you're highly likely built a resilient environment. If you see a lot of anomalies or differences, then it's time to iterate and dig deeper and find out why. So testing your hypothesis is very important. So I'll go back to the kind of the methodology or philosophy of Netflix chaos engineering. How many of you have heard of Simian Army? 1, 2. I'm not gonna minus you. Every question. Okay. So Simian Army is this is a concept that Netflix has developed. It's in GitHub, so you can look this up. And basically what it is a bunch of rogue applications, so to speak. And they all have monkey names. So Chaos Monkey, Gorilla Monkey, Gorilla this, Gorilla that. But anyway, the objective of these monkeys or these tools is to actually forcefully break the environment, right? Without any prior knowledge or anything. You just send these cron jobs or these applications, and they start tearing things down. And then they look at customer impact, downtime, what went wrong, logs, and then start to build the environment in a resilient way. I don't recommend that you go and start with this right away. It's good to read, and it's good to think in this fashion, right? Because this is actually, the way Netflix does it is a little bit more advanced, where it actually goes into production environment and starts yanking stuff out. It'll take a cluster of EC2 instances, it'll take EBS storage, it'll break security groups between two clusters. So it's very, very impactful. But for them, obviously, they have teams, what we call a war room, where they actually are ready and prepared to investigate. But the idea here we like to share is, once you build your environment, you decide on the steady state, and then you do those experiments. Now try to introduce failure into the production environment, minimizing impact on your customers. On a high level, when you talk about high availability and redundancy, you want to make sure to look at these three kind of pillars. And these pillars are, so the problem usually is a failure of a specific service or a location. So to mitigate that, you want to build in a multi-AZ fashion. You guys familiar with availability zones and what it means? Yes, no, 2, 3, 4? Okay, so availability zone is basically a separated data center, right, with that's connected with different power grid, networking. It's completely isolated, right? So when you build your application in a multi-AZ fashion, you're basically taking advantage of two data centers. So run across multiple availability zones or even regions. So to be able to handle spikes, for example, and this is kind of a low-hanging fruit. You launch a new application and you're expecting a large volume of spikes. Leverage auto-scaling. So auto-scaling is something that you can deploy right away, very easy, in conjunction with the CloudWatch, where you can scale up and or down as you see fit. And there are parameters that you define, right? When I reach 80% CPU for this period of time, increase by. When I decrease my CPU by X percentage for this period of time, decrease by. And avoid single point of failure. So look at your architecture as a whole, and you should not have any single point of failures at all. And you can leverage, again, multi-AZ, you can leverage backup, elastic load balancers. These are all technologies that are available to you today within AWS, where you can completely remove the single point of failure. Now we'll move a little bit up the stack. So standardizing on libraries and design patterns is very important. So when you're thinking about production readiness and you're writing code and trying to ship code and you're getting ready to close to production, think about standardizing on libraries and languages, even on styles and guidelines. And there are tools actually to help you with that, like ESN-less or GeoFMT. And these tools help you make troubleshooting easier. Even later down the road, if you have compliance requirements or additional security requirements, you'll find yourself at a better place because you're standardized, your code is clean, it's well documented, and you don't have kind of anomalies or just ad hoc languages all over the place. Spot situations where your code may be duplicated and be able to be refactored. Look for opportunities to implement good design patterns. And last but not least, know your licenses, right? Difference between open source and GNU or MIT Apache. So these are best practices just before shipping code to think about and implement ahead of time before you actually push code. Security. Security is very, very important. At AWS security, we call it security is job zero. It's even before number one. So always think security whenever you're thinking about launching your code or production readiness in general. So with security, ensure that, and I heard this on the previous, during the previous presentation, it's very, very important. Never store credentials on your application. And you can kind of tell, we keep repeating this over and over. So don't store credentials on your application. Be sure to code defensively. So protect yourself against SQL injection, cross-site scripting, and there's methods and open source libraries out there that can help you develop or adopt best practices, right? For example, to code defensively against SQL injections, least privilege is one way. Another way is against SQL injection. Another way is, it skips my mind. I'll get back to it. But there's a couple of techniques you can utilize to defend yourself from the beginning, code defensively. Consider pre-commit by Yelp. How many of you have heard of it? The pre-commit by Yelp, it's also on Git. So take a look at that. So what it does is really, it's an open source software that allows you to pre-commit your code before you actually commit and look at anomalies, look at code issues, look at anything that's kind of buggy with your code before you push code to production. And this is all open source tools. These are all open source tools that are available to you. Last but not least is try to leverage other startups. I've worked with customers that have this cadence where they do every last Friday of the month, they work in a kind of a shared space, and they invite developers from their neighbors or in-neighbor company, and then they look at each other's code and try to see if there's some kind of ways of improvement, what can be done better. Another way is even within your team. So if a team is working on, say, microservices and another team is working on another project, have those teams a kind of cross-function so you can get a different perspective. Because we tend to, I'm guilty of it, to get that narrow vision or kind of a vacuumed look, and we think this is it, this is the only way. Get the different perspective even within your team or outside. And those customers that actually I've worked with that do cross, not teams, but cross-company or cross-startup code review have mentioned that they've realized a lot of benefit. Monitoring. So with monitoring, there's a couple different levels of monitoring and alerting. So there's a service level monitoring and application level monitoring. With these types of monitorings, you want to identify first what's critical, what's important, what should I notify on, who should I page at 3 a.m. in the morning, and what kind of issues should I page for or not. So what I mean by that is for service level monitoring, you want to make sure to create a classification of your application, whereby if, for example, I'm running an e-commerce website and my payment system is down, everybody should get paged because we're not working, we're not open for business. However, on the application level, if, say at midnight on Sunday, I have an alarm of some kind of throughput latency, right? Minor. Should I page someone at 3 a.m.? Maybe not necessarily. So classify the way you're alerting and monitoring, right? What's important and who gets paged, and what's less important, and does it worth a page in the middle of the night, or it can just be an email to a group, an alias. Performance metrics, this is very important. Obviously, if you can't measure something, you can't do anything about it, right? So start building dashboards of important metrics. This is very critical. Ties back to what I just said before about classifying your applications. So those applications that are critical to your business, right, or to your environment, make sure that there is a way to have them in a dashboard. And there's third-party, obviously, tools out there, open source and not, where you can have a dashboard so you're aware of all the anomalies, issues, blips, hiccups that happen to that application. Because you want to be able to be aware right away, right? So if we use the analogy of pillars, for example, if we remove pillars of a building, it will collapse. So you need to look at your application and know what are those pillars, and you need to be notified on those right away because you don't want the business to collapse. Now, if a piece of tile is broken here or there, that can be fixed the next day. So you always think to have metrics that are being gathered. So, so the second point is when you build this metric about the pillars, so to speak, you think you're done, right? And then the moment an issue happens or you have an alert or alarm, then you figure out that you didn't measure a specific metric and now you need it. And this just comes with experience. There's going to be things you're going to miss and they will rise when the time is right, and you have to add those and classify them as well. Is this priority 1, 2, and 3, etc.? One more important item here on monitoring is average highs issues, and there is a reason why we put it in bold there. So when you're setting up your monitoring systems, make sure you just don't look at medium and average, or median and average, right? Look at your system in a percentage style, because when you go with average, it hides the big anomalies, and I'll show you an example here. And if you miss those anomalies, even though if they're small, they can be very impactful if you have a large user base. Plus, in order for you to be successful in digging deep for root cause analysis, you need to know exactly where that anomaly happened. Otherwise, it just goes right by and you never see it. So more about application visibility. So here, you want more insight in your application, right? So you want to dig deep into the performance of the application itself. So you want to be able to know how long are the calls being retained, right? You want to know if the issues are trending up or down. You want to know what part of the application generating most number of errors. So make sure you utilize a tool, application level monitoring, so you have a deep understanding of your application's behavior. This is an example of looking at latency in function of time, where we'll look at the mean and median. If we look at this example here, I mean, there's a little bit of a blip around 936, but it's not enough to raise eyebrows, so to speak. But if we switch to percentile, now we have a problem. So you can see how at that same time, 936, we have a giant spike. And also at 448, we didn't see anything on the previous time. So you want to make sure always leverage 90, I want to say 95 percentile. I came from a network engineering background, so not 95 percentile, but percentile in general. So you can peek and dig deep on these anomalies and find out why there was a spike there. Different types of monitoring. There's the synthetic monitoring and real user monitoring. So synthetic monitoring is also known as proactive monitoring. So don't wait until things happen, because real-time monitoring is that, which is it tells you exactly how your users are interacting with your application, and it reports back to you, and then you're reactively making actions, right, or taking actions. Synthetic monitoring is proactive, so try to emulate the user experience. As I mentioned earlier, if we take the example of e-commerce website, right, and I have a user that comes in, enters their information, credit card information, clicks a couple of places, buys a few things, checks out and leaves, emulate that experience and see where the application is malperforming, so to speak. And if everything works great, I'll tell you what you can do later to break it. Because you want to make sure, if everything was great, that's good, but you want to make sure you introduce errors, you introduce issues, because that's the only way for you to find out the hard way or the easy way, how to react to those problems. Because if your application works well end to end, the day something goes wrong, you're going to be scrambling. Might as well just introduce it yourself and find out. A good analogy that Netflix team uses that kind of ties into what I just said is if you drive a car, you know that you have a spare tire, right? So if you have a problem with your tire, you can just stop and change it. But you don't necessarily know if the tire is inflated. You don't necessarily know if you have the tools, or if they are in the trunk, someone removed them. So if the tire goes flat, you assume you have a flat tire, or you have a spare tire, you open the trunk, and it's like, oops, my backup is failed. So make sure you introduce that failure. Punch a hole in the flat tire, in the tire, and go find out if you have a spare tire. Monitoring, continuous monitoring with circuit breakers. How many of you are familiar with the concept of circuit breakers? Well, okay. So this is a good concept to adopt. It is somewhat similar to load balancing. So if we flip this diagram clockwise, think of the API as kind of a load balancer, right? Sending loads to different areas. So on the right there, think of it, again, same example as e-commerce. Customers, like where the customers enter their data, the order forms and invoices, right? And you have API calls coming from clients, everything is working fine. Now all of a sudden the invoice section of your system is experiencing latency. So what do? If you don't apply circuit breaker methodology, this can be painful for your consumers. So with circuit breakers, what will happen is, and there are tools I can share with you, and third-party tools that you can leverage to help you with circuit breaking methodology. It helps you with error handling and rerouting of traffic. So then the traffic doesn't keep going to the areas that is experiencing high latency. Sorry, oops. So reduces error rate, and then it'll eventually mitigate the issue. Some of the tools that you can leverage with excuse me, sorry. Yes, so service mesh and Linkerd. Have you guys heard of Linkerd? Yeah, so Linkerd is a tool that you can look up that can help you with auto discovery, rerouting, and mitigation when it comes to circuit breaking technology or methodology. And this diagram really illustrates kind of circuit breaker as a whole, how it works. When everything is successful, you have a clean loop, right, from open to closed. And if not, it goes back and keeps trying. So make sure you have, you leverage, like I said, Linkerd, because it's a transparent system that kind of allows you to do auto discovery, rerouting, right? Because if you have, for example, microservices and invoices is in one section, and then that section is getting hit a lot and you're experiencing high latency, Linkerd can help you kind of reroute to a different container or application. Now we move on to login. So with login, what's important here is to think long-term. So what I mean by that is try to adopt a framework that's going to help you in the future. JSON is a good format for login, and the reason why we say that is because it's compatible with most third-party applications out there to help you if you're going to do data analysis or deep analysis or any kind of business analysis with it. Add context to your login statements so it makes sense. Log behaviors and errors. And consider how analytics will be used with your data. Again, that ties into that unify your logs if you can, as much as you can, to a framework or a language that can work across platforms. And JSON, we found that JSON is one of them. Another thing that you can do, have you guys, any of you using data lake or know what a data lake is? No, okay. So data lake is basically an aggregate of lots of different data. It can be logs, predominantly logs, but it can be any kind of data. But the trick with that is, the reason why it's called data lake is all these streams come in different formats. So you have JSON, CSV, text, all kinds. And then we have customers that want to run queries against that. But the format is all different. So the idea of data lake is to be able to take all those different formats into a data lake and then run queries against those that data set. There is a tool with AWS. It was launched earlier this year called Amazon Athena. You guys familiar with Athena? Yeah. So Athena does exactly that. So Athena allows you to run interactive SQL queries against S3 bucket, which is data lake, regardless of the format. So you can use JSON, CSV, text file, all kinds of formats. But in a long-term thinking, for the purpose of this conversation, try to pick a language that will help you down the road. UTC timestamp. Some people think, or sometimes just skip this part, right? Or think like, oh, who cares, right? Well, actually, you should. Because the argument is, well, our environment is deployed in US East. Why should I care about West or UTC? You would care about it because if you grow and you start having customers or even another pod or deployment in Europe or APAC or even US East and West, then you're going to have to do conversion, and it's not fun. If you have logs coming from all different places and you have to do time conversion, it's going to be very painful. So unify your timestamp into UTC, because then it's UTC minus, right, or UTC plus, and you know exactly what you need to do. It helps you a lot, especially when you start going global. Another thing that we found that was very interesting through a customer is getting rid of the sub-second field. If you don't have a need for sub-second field, just eliminate it. It helps with a couple of things. Performance, when you're querying against lots of data and it all has a sub-second field, it takes longer, right? So get rid of sub-second if you don't need it, because mostly you would need, obviously, date, time, minute, and second. Sub-second is not that relevant. But if you get rid of that, it will help you with performance and cost and a lot of other things. Again, continuous on login, individual transaction, and IDs. So what I like to highlight here is the level of visibility you should always expect from your application. So in order for you to troubleshoot or to get to root cause analysis, you have to have a good X-ray vision, so to speak, of the entire process or life of a packet, so to speak. Like your application, you should have end-to-end visibility. So right here, we'd like to tell you that you should have a session ID logged, right, that generated the error. You should have who the user is, right, that encountered the error. You should log the user location in the application, right, the user location in the application, the ID of the transaction of product that caused the error. And last but not least, just be careful. If you're dealing with PHI data, right, health, personal health information, or PCI, you want to make sure you consult with your InfoSec team to make sure, hey, is this type of data we can log or not? That's the caveat. But in order for you to do root cause analysis on anything, you have to log all of these elements to have a good vision. Again, I want to tie this up to AWS X-ray, if you guys heard of X-ray. But X-ray is a tool that allows you to do exactly this, right? End-to-end X-ray vision of the entire cycle, right? When a user logs in, what happens after that, what happens after that to the end. So you can kind of laser focus on what you need to troubleshoot. Documentation of your code. Again, this is another very, very important element. Sometimes it can be overseen or kind of pushed to the bottom of the list, but try to adopt this as early as you can. The more work you do now, the less you're going to have to do later. And it's actually easier to adopt this early than later. I'm sure for those of you who are coders, will agree with all of this, right? Make sure you document what the code does, right? First of all, README file. Within your code, have good comments, right? I used to be a developer in my past life, and it drove me nuts when there was poor documentation or comments in the code. Like, you have no idea. You know what's going on, but there's like all kinds of redundant stuff. So make sure your code is clean and it's well commented. Instructions on how to install it and run it, what it does, how to stop it, start it, kill it. Also, dependencies, right? When you stop this code, what else can happen? What else is going to be impacted, right? When you start it, what other dependencies does it have on other tools or other codes? So make sure that's all documented. How to configure it, how to troubleshoot it, and then what metrics are available in the dashboard for that particular code. This is going to be very, very helpful because when you start to grow, let's say today you're a three people or 3-person team, right? By half of the year or next year, you double, you're 6 or 8, right? Then instead of going and doing a 1-hour session with each new developer, you don't really have to. You hand them the code, self-sufficient. They look at it, they can hit the ground running. So this is a good investment early than later. If you do this later, you're going to pay the price because now you have to go backwards in time and what was this again? What dependencies do we have here, etc. So all we're going to talk about today, production readiness, is all things that you should do before you jump into production. Now we're going to move into alerting. So, mean dog. So with alerting, a rule of thumb that you should think about is that if you can define a runbook, that should be automated. If you have a runbook of a process, that you should take that and basically automate it because a runbook is steps, right? Do this, then do this, then do this, then do this. So think about automating as much as you can, especially level 1 operation stuff. There's a lot of tools. Again, there are tools that are native to AWS like CloudWatch, but there is a really good tool called Monit that helps with all this level 1, bless you, all this level 1 kind of monitoring where you want to get system alerts, CPU, things like that, right? Automate, just automate. Don't even, wait for someone to write a code or a cron or anything. It's available. These are tools that are available to you. The other thing that I'd like to highlight is, are you guys familiar with the EC2 auto recover? EC2 auto recover? Yeah, no, yes? Did you say yes? Yeah, okay. Yeah, so EC2 auto recover is a really good tool to look into. And this is a tool that comes with AWS, your AWS account. Let me just skip right to it. Auto recovery. And what this does, this tool does, is it allows you to automatically move your machine image, Amazon machine image, or EC2 instance from a physical host to another in case of an event, unlikely event. So what this does is, if there was an issue, right, there's a status check fail system. If there is an issue with the underlying host, so we have a lot of checks behind the scenes that look for power failure, application level failure on the host, network failure, and many other things. When we notice those, you can automatically say, hey, move my virtual machine to another physical host. And that can happen automatically. Now the beauty is it doesn't just move your machine, but it moves your machine, it moves its ID, it moves its private IP, public IP, if you have given it one, and EBS storage. So it moves all of its identities with it. Leverage this because it's going to save you a lot of time. If things fail, like we said at the beginning, things fail all the time. But if, in the unlikely event, a host has a glitch or an issue, move your EC2 instance. It moves all of its identities with it, and it's all automatic. You'll get a notification. You're aware. Your team will go in and make sure your application is actually launched, everything is good, but at least you're not doing the heavy lifting of figuring out why is my EC2 instance not responding, etc. Leverage auto-scaling, which I mentioned earlier. So auto-scaling helps in a lot of ways. Again, you can set thresholds, usage, right? CPU reaches this much, or this percentage for this much of time, then lower. You can also leverage auto-scaling with, let's say you have an instance that's experiencing high CPU, right? The assumption is like, oh, maybe we're getting a lot of requests. Now, use auto-scaling to handle the request, but then go back to that instance and look and see, is it really, are you really having a lot of users, or is it just the instance that's having issues? Or is it code? Sometimes we neglect code, right? We push a new version of code, and then that code does something funky, and all of a sudden CPU is up, but the users or the number of requests you're having are the same, didn't change. So auto-scaling will help you serve traffic, but also give you that flexibility to go back and mitigate and look at that instance and find out why you saw that spike. With alerting, make sure you have proper escalation paths and alerts. With proper escalation paths, you want to make sure that you have at least, this is, by the way, assuming you have more than 2 people in a startup. If you have 2 people, they're all going to be right there. They're going to be the escalation, they're going to be everything. But if you have more than 2 people team, then this is a best practice. So you want to have a primary person, right, that always gets paged. And who is the primary person is most important. So I'll tell you what we do at Amazon. We adopt a culture of, if you build it, you fix it. So if you build something, you're the one responsible for on-call. You're the one responsible to fix it, not someone else. So you want to make sure you have a primary person, preferably 2, because oftentimes the person on call just happens to be in an area where it's dead in terms of signal, or in the basement, and then they don't get the call, and then it stops there, right? And then you have an impact. So make sure it's 2 people. And then after that, make sure you set up an auto-escalation every 10 minutes. If there is no action taken, it should escalate to the secondary level. And if after that, it should hit a team. And after that, it should go to management. And this should be an automated process. I'll give you an example. In my past life, I used to work in a kind of a SOC, NOC type scenario. And we had a unified kind of pane of glass, so to speak, for alerts. It was very, very highly automated. And it lessened chatter, it lessened chat, it lessened talk, it lessened all of that. Why? Because when there was an event with an application or infrastructure, first it showed, and it shows severity. It gives you all the details, IP, source, everything. Then we had, as network and security engineers, we had an SLA of 5 minutes to own it. So within 5 minutes, somebody from the team has to own it. So once you own it, then everybody in the team, no matter where they are, because we were global, they know Yazid owned this one, so it's good. Then after you own it, you have another SLA to resolve it. And everything was automated in the sense of if it's not resolved within a specific period of time, it escalates. It goes red, and it moves to team, then manager, etc. So adopt some of those methodologies. Again, there are lots of open source tools out there where you have a portal that aggregates all of your, which my colleague earlier talks about log aggregation, but this is more alerting. Aggregates all your alerts and classify them, right? Is the website down? Is the payment gateway down? Is someone experiencing low latency? That might be kind of a low severity type incident. So auto-escalate when issues are not acknowledged. So as I mentioned, if you don't own the issue, then it should auto-escalate after 10 minutes, right? So you don't need to email a team and say, hey, are you on this? Are you working on this? It's just centralized. To that earlier point that I just mentioned, that's what we adopt at AWS. So developers should own the burden of fixing the code they build, right? You build it, you fix it. So, but typically what we see is whenever we notice, bad application code, for example, that triggers a 40% increase in CPU, the easy way out is throw more resources at it. So short-term fix is you throw more capacity and then problem solved. Yeah, no problem. Not really. The problem is you need to go back and look at the code and find out root cause. Why is it bringing that 40% CPU, and then fix it by doing root cause analysis and finding out why. So capacity is only short-term fix. Long-term fix is root cause and find out why the code is acting that way. Now we're going to move on to service level agreements. So service level agreement is kind of a big word, but we'll go ahead and kind of walk you through methodology and how you should think about service level agreement. So the way you should think about server level agreement is not by a blanket statement. So you shouldn't think, okay, my entire stack should just be up all the time. It's good to think that way, but when you talk in depth and detail, you should break that down into, again, classify, right? So I'm going to, for my search portion of my website, for example, I'm going to expect 99.99% of the time to be up. For the cart, that's the highest, which is the shopping cart, I need 5 nines. And for the avatars, which is where my customers can go and pick an avatar while they're shopping, I'm just going to do 3 nines. So classify your workload in relation to its importance, right? The more important the workload is and critical it is, the higher the SLA. So try to get away from a blanket SLA into service level SLA by specific service. So the reason why I say this, because it can be very, very, very expensive in human resources and financially to have a blanket SLA for everybody. If we just want to say, I want 5 nines for everything, it's doable, but it's going to take you a lot. So try to break that down by criticality. What's critical? I'm going to give it this many nines. Less critical, this many nines, etc. So on and so forth. This is important when using microservices. For teams to reliably build dependencies on your service. Obviously, when your team builds a service in microservice environment, they already know what the SLAs are for the cart. So if whatever they're building isn't going to be in the cart or part of the cart, they know we're expecting 5 nines. So that architecture needs to evolve around 5 9 availability. But if they're building an avatar, then they know it's only 3 nines. So we shouldn't put too much resource ahead of it. So this helps with one, efficiency. It helps with resiliency in relation to importance of your system. And it helps with financial. So you're not spending so much money just building this giant castle where you just need maybe a house. And SLA can also be tricky in the sense of, how do you achieve 3 nines? How do you achieve 1 9? How do you achieve 4 nines? And I can show you a little table that can help with identifying the downtime, how to achieve a 1 9 all the way to how to achieve 6 nines. But really the way you want to look at this table is you need to categorize first the applications, then you need to look at the impact and measure that. So what I mean by that is you want to look at, I'm going to go back to that example of a shopping cart. If the shopping cart is down, what does that mean to my customer? So that means they can't buy anything. Okay. Now, how do you translate that into business? If you can take that and map it into business impact, and if I say my users or my shopping cart can be down for 2.5 hours, right, or 2.4 hours, what is the business impact, right, to your business? If you're down 2.5 hours, nobody can buy anything. So that's how you should think. You start from there and work backwards. Now, if I look at the other extreme, which is avatar, what does it mean if my users can't pick an avatar for 2.5 hours? They just can't do it. How does that impact the business? I'd say not so much. They might get some angry people here and there, but they can still buy. But the buy-in is very important. If they can't buy, you're losing business. So you want to classify your applications in that fashion and work backwards. So I actually double-checked the math here. It's actually correct. So I don't like slides that have numbers that I didn't run by myself. So I was like, I'm going to double-check. So the math is actually spot on. So this is what you need to do. For 2 nines, you're going to have an uptime of 99%. Your total downtime per year is 3.65 days. Downtime per day is 14 minutes. Now, you want to ask yourself, is 14 minutes acceptable? And if the answer is yes, great. If no, how can we reduce that? And what does it take to reduce that? The slides, by the way, will be shared after you do a survey. You don't need to take pictures or anything, so you can have this. This is very important. So load testing. So now we're going to talk about load testing and understanding your limits. So clearly, before you go live, you want to make sure you load test, right? Make sure you put heavy load on your application to make sure what your breaking points are or not. Is it bandwidth? Is it throughput? Is it auto scale? What do I need to do? Know your bare minimum, which is what we talked about at the beginning, the steady state. What is the steady state? If I launch my application today, right, normal business, I need to know what is the minimum to just run my application. Another common term for this is how to keep the lights on, right? Just the minimum. I want to keep the website up and running, just normal traffic. You want to know what that minimum is, and it becomes your baseline, and then you build on top of that. Know your maximum throughput that you can handle or your architecture can handle. Because once you build your environment, it's going to have its minimums and maximums. So know your limits. When is the threshold where I'm going to need to start thinking about it, auto-scaling? Where is the threshold when I'm going to start thinking about adding some more microservices? When is my threshold where I'm going to need to launch new database cluster? So you need to know those limits. And then you set alerts on those limits so you can be notified ahead of time, because we can somehow know when we expect large traffic, if there is some kind of acquisition, or maybe you're preparing a large marketing event. But really, if you look at it, you're not sure. Once you launch a product, you just wait, right? It might launch, it might go viral, or it might not. You want to know where that limit is. And calculate your throughput per instance ratio, so you can accurately, properly auto-scale. So this is kind of advanced level of auto-scaling. Instead of auto-scaling by a specific number of instances, you auto-scale in a percentage fashion, right? Instead of saying add 2 instances, you say, I want 10% more, right? So that way you're very, very lean. But you can only do that if you know exactly what your throughput to instance ratio is. So you need to do monitoring, have good visibility, right? A lot of testing in order to do this. So again, this is what we just talked about. Increasing or taking action or using auto-scaling on a percentage-based versus number of instances. Again, the performance baseline for the future. Always think, whenever you launch code, this example actually talks about version 1 of this code, and we moved from version 1 to version 15. So your code evolves with time, right? You're evolving your code, you're sending patches, you're just adding features. As your code evolves, so does the infrastructure running it, right? The underlying infrastructure. So make sure you understand the relationship there. As your code evolves, what does it mean? What are we increasing? Why do we need to increase? And in certain instances, you might actually decrease, right? Instead of having, say, a cluster of large instances for V1, V14, because we did a lot of tweaking, right, on the application and modernized it, we're going to use multiple medium-sized instances. So think about that. Think about how code evolvement impacts the underlying infrastructure, right? Are we just growing, or can we consolidate, shrink, or can we decouple further? So that kind of a mindset. So this example here talks about how we see a 63.58% increase in performance from V1 to V14, and this directly correlates to the infrastructure cost. As you modify your code, so does the underlying infrastructure. Now we move on to testing. How are we doing on time? So with testing, you want to kind of, I hope I'm not telling you anything you don't already know here. So with testing, you want to follow the kind of the foundation about testing, which is you plan, you code, you build, continuous testing, release, deploy, operate, monitor, rinse and repeat. So you kind of follow that cycle. So you want to build confidence in your code, right? Before being released. Allows you to test more of your application in less time when you automate, right? So you're not doing everything manually. And then manual testing error prone is removed. So again, back to that human intervention. Remove human intervention as much as possible and just automate, automate, automate. And again, plenty of tools out there, AWS, code pipeline, CI/CD, all the CI/CD stuff, code pipeline, code deploy, code build, and plenty of other open source tools that you can leverage to help you automate and remove human involvement. Because the less you have to do manually, the less error prone your environment is. Test-driven deployment. So this talks about build, test, develop code so that it passes, and then refactor, optimize code. So kind of a similar cycle, right? Rinse and repeat. So always build, test first, look at those failures, reiterate, develop your code, obviously with the intent that it's ready for production, put load tests on it, and then rinse and repeat, rinse and repeat. Automation is really the takeaway here, automate and automate. Deployment strategies. So with deployment strategies, you want to think about how you can be less disruptive, right? So how many of you are familiar or are using canary or blue-green deployment? Are you familiar with blue-green deployment? Anyone? No? Okay. So these are methodologies you probably want to look into, and they help you with code deployment and less impact, right? So when you say you have a V1 code that's up and running, and then you have V2 coming up. So how do you do that without impacting users? So there's a lot of techniques you can use. Canary is one of them. Blue-green deployment is one where you can launch, and we'll dig deeper into them in the next couple slides. But really the premises here is that you can deploy a new version of code with less impact. Most importantly, you can revert. Because sometimes you push V2, something breaks, what do? Right, you want to go back. So this talks about kind of, think of code deployment as kind of a database, because you don't want to interrupt, the flow of your work. So in a database world, for example, you don't remove columns, right? You remove a column, that's a big problem in a database. You only make additions to reduce risk. But let me jump into the canary pool and kind of blue-green deployment. So here, as you can see, we have a load balancer. We have version 1 of code, right? And version 2. So what we do is we launch version 2, right, in its own little cluster. And version 1 is still working up and running, no problem. And then on the load balancer, we set a waiting condition where we say, send 90% of the traffic to V1 and 10% to V2. Why we do that? Because we want to, one, not impact our entire user base. And by the way, we're just using these numbers as an example. You can do 95 and 5. You can do 80 and 20. But majority has to stay in V1. Then once you run the 10% on V2, you observe. If everything works great, you can increase the traffic a little bit more, 20%, then 30%, and so on, until you go to 100% zero. If things go wrong here at 10%, then you stop. You move that 10% back to V1, right? Minimize impact, and go and investigate. Why did the application crash? Why did we have this issue? So this is one of the most seamless ways where you can kind of have V1, V2, or application versioning deployment without impact to your end user. And you want to have a way to revert back. And what you see there on the right is basically a successful migration, so to speak. We started with 90-10, and then we moved to a 0, 100%. And then within the deployment strategy, to go a little further into it, there's a lot of techniques, so to speak, that you can adopt. And again, there's no one secret key for all. It all depends on your business requirements, your application, your end users, your tolerance, you know, a lot of things. But this is good to know as a whole. So the opt-in method, the kill switch method, scalable rollout, etc. So the opt-in message is basically you select a specific group of users, and only those users have access to the new version of the application, right? And you get feedback, and those users can be customers, can be internal, can be preferably external people, right? Also known as beta or preview. So, you know, sometimes you hear beta, so only a certain group of people, because that gives you the feedback, it gives you lots of information before you go live. You want to make sure you have a kill switch. If the application starts acting up, you want to make sure you have a way to revert back and just get rid of it without impacting all of your users. Scalable rollout is what we saw in the previous example, which is you do 90%, 10, and you wait. And as you see that application is acting properly, add another 10 or 20%, right? 80, 20, 70, 30, until you move everything, because that gives you a chance to revert back. And load balancer is very easy, very highly automated. You can literally set the wait condition there, and it just works. Block users, so prevent users from using this feature. So you can launch a feature, for example, internally in the company, and only have a specific group of users have access to it, and the rest don't even know it exists. And you can do that by a feature flagging. Yeah, right there. So if you're not familiar with feature flagging, look it up. It's a very, very cool feature. This allows you to exactly do this, where you can, in the same environment, same group of people, I can choose that these 5 or 10 people on this side can have access to my V2 application, and this group will not even know about it. But you're using the same application, right? So that's kind of, it's done with feature flags. And there are tools also, open source tools that you can leverage for this. A and B testing, test and compare new features, and then sunset old features. So sometimes you just, obviously once you move on to that, we start from 90-10, and then you move on to 100-0, you sunset V1. V1 becomes obsolete, and then your V3 is the next iteration, right? So on V3, you repeat again. You do 90% on V2, 10%, and then you move on from there. But feature flags is very important. Look it up. It really helps with kind of isolating users seamlessly. Okay, error budget. So this is also important if you have it. Not very many people have it, but if you do, spend it. Error budget really talks about, in some companies they have what they call error budget, like likes of Netflix and so on, where at the end of the year you have a specific allocation of money that you need to spend on your environment in terms of testing, resiliency, robustness, etc. If you have it, use it. Meaning, if you can afford to run a duplicate of your environment, like a test environment, but almost same, identical, and run tests against it, do it. It can be, it comes with cost, obviously, but if you have a budget and you can do it, this is very, very important, because you will only find out what's wrong with your application when you introduce problems. And if you, let's say you launch your application and it just works perfectly, you should introduce errors. You should introduce errors at all levels, right? From the system, application level, all kinds of levels, storage level, database, make sure that you're aware of what's going to happen, right? You want to do that in a practice environment, not in real, right? You don't want to do it in your production environment. So some companies are forced to spend their budget here when not utilized, and they're encouraged to build gracefully fail. So this ties into to that Netflix Simian army I mentioned at the beginning. So this is part of why they kind of use the Simian army to go and test the resiliency. Because you can build a really robust, resilient, highly available environment, but you only find out the weaknesses when something goes wrong. Now, instead of you waiting for that when something goes wrong, introduce it ahead of time and find out, so you can learn how to mitigate and also learn how to build against it, right? So there's ways where you can find out, oh, we had a single point of failure which we didn't know about. Now we need to solve for that. And this kind of summarizes what we talked about. So production readiness review. So we talked about architectural design review. So this is where you want to avoid single point of failure, multi-AZ, do that kind of team, cross-team pollination, so to speak, if I might use the term loosely. So have other teams look at each other's code. Monitoring, so this is important. Remember, try to aggregate your monitoring tools into kind of a single pane of glass if you can. And the more data you log, the better you're going to be at root cause analysis. Remember when we talked about what you should log end to end, right? The entire transaction should be logged, and it should be available to you so that if something goes wrong, you know what to look for. If you don't have timestamp, for example, if you don't have IP address of the requester, if you don't have specific application area where that error occurred, it's very hard to get to root cause analysis. Documentation, standardize on code, document what code does, what its dependencies are. Do that now rather than later, because you're going to save a lot of time. Alerting. Have a system in place where the right people are getting alerted for the right reasons, right? Don't alert someone at midnight when a customer can't choose the right avatar, but do alert everyone if the shopping cart is broken. Service level agreement, again, look at the business side and see what the impact is and work backwards from there. What does it mean for me if my customers can't buy? And how many nines do I need? What does it mean for me if my customers have sporadic latency, right? And build a table on the SLA, right? Don't have a blanket SLA for everything. Have an SLA per service. Know your expected throughput. So this assumes that we've already done everything and the environment is ready to go. So know your baseline. What is the expected throughput? How far can I push the envelope, so to speak? Meaning, where is my limit, right? From an infrastructure side, from a throughput side, from the application behavior side, you want to make sure to know your limit so you can plan for increase. Testing, 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 and testing. There is only one way to find out, is to test and test and test again. And last is deployment strategy, right? So the deployment strategy, which is what we talked about, the canary, blue-green deployment, learn how to shift, right, traffic from one cluster to another or one microservice to another without impacting your users, and ability to revert back to it. So deployment strategy is very important. And feature flagging. Remember that feature flagging, where you can send a specific set of features to only a group of users, make it visible, so to speak, and then the rest of the users wouldn't even know about it. And you do that just so that if there is an impact or an issue, not everyone is affected. So it reduces your risk, and it reduces having a widespread impact on your application. And I think after that, there are some resources which you will get. This talks about the circuit breaker, which I talked about, the feature flag, error budgeting, monitoring, and then production readiness. This is really, really good information, which you will get from the team after the survey. And thank you very much. I'll be around for questions if you have questions. Yeah.
All right, thank you guys.